everyone, welcome to the video series lecture of thermodynamics. So today we are going to start a new chapter, that is the heat effects. This is very small chapter and it will cover in this lecture. So what points we will discuss in this lecture? First we will discuss about the sensible heat, then we will discuss about the latent heat. After that we will discuss about the heat of formation, then heat of reaction, after that heat of combustion, and then at last we will discuss about the Hesh law. So today we will discuss about all these topics. Okay, so first we will start with the types of heat, that is the sensible heat and the latent heat. Now what is the meaning of sensible heat? So we know that always when we transfer the heat to any substance, that will cause the temperature change. Okay, let us take one example. If you have water at 10 degrees Celsius and when we supply the heat to that water at 10 degrees Celsius, it will continuously rise the temperature. Okay, so the temperature of water will be rise from the 10 degrees Celsius to 20, 30, 40 degrees Celsius. Okay, so the heat which is required to do the temperature change, that heat is known as the sensible heat. Okay, now the second one is the latent heat. What is the meaning of latent heat? Latent heat means the heat which is required to do phase change. Okay, let us take the example. If we have ice at 0 degrees Celsius, then we can say that from that 0 degrees Celsius ice, if we want 0 degrees Celsius water, then compulsory we have to supply some amount of the heat at 0 degrees Celsius ice. So the heat which is required to convert this 0 degrees Celsius ice to the 0 degrees Celsius water, that type of heat is known as the latent heat. So what is the basic difference between the sensible heat and the latent heat? Sensible heat means the heat will create the temperature change, and the latent heat will be doing the phase change. Okay, so heat which is required for the phase change, that is known as the latent heat, and heat which is required to change the temperature of any substance is known as the sensible heat. Okay, so these two are the basic heat. Now what we are discussing in the next topic, that is the heat of formation. Now what is this heat of formation? Okay, sometimes this heat of formation is also known as the enthalpy of the formation. Okay, so if we have some elements and from that elements, if we make one product, then ultimately we can say that there is one formation is occur. Okay, and at that time the heat which is required, that is known as the heat of formation of enthalpy of formation. So you can read the definition also. It is the enthalpy change for the formation of 1 mole of compound from its component elements. Okay, so if from the elements, if we made 1 mole of compound, then the heat which is required at that time, that is known as the heat of formation. For the example, formation of carbon dioxide from the carbon and oxygen, and formation of any chemical from which we can get some product, that is known as the heat of formation. Okay, so ultimately you can see here I have taken one example of the carbon dioxide. You are familiar with this example, that C plus O2 will make the carbon dioxide, that is the CO2, and at that time the heat which is required to do that, that is known as the heat of formation or the enthalpy of formation. Okay, so C plus O2, that's CO2. So here one reaction is occur, so that change of enthalpy for the reaction we can mention it by the delta H of reaction. The same we can write here, that the delta H for the formation. Okay, so the delta H for the reaction is equals to delta H of the formation of the carbon dioxide. Okay, now next we will talk about the sign convention for the heat of formation. Okay, so as earlier we have discussed in the first law of thermodynamics, the same sign convention we have taken for this. Okay, so simple, if the heat is supplied from the system to the surrounding environment, then we can say that that type of heat is negative, and if the heat is supplied to the system from the surrounding, then we can take that heat is a positive heat. That we have already discussed in the first law of thermodynamics. So same type of sign convention we have used here. So here you can see if the delta HF is less than 0 means the heat of formation is less than 0. Then we can see that here the heat is released. Okay, so when the heat is released, or we can also write heat is released by the system. So when the heat is released by the system, we can say that that type of heat we will consider as a negative. And second one is the positive, when the heat is absorbed by the system, when the reaction is occur. Okay, when the C plus O2, if the heat is absorbed during this reaction, during this formation, so when then we can say that here the change of enthalpy will be positive. Okay, or the heat of formation will be positive. So here you have to understand, when it is negative, when the system will release some heat, or heat is going from the system to the surrounding, and second one is the heat is positive, when the heat is absorbed by the system. Okay, so ultimately it will add some energy to the system, so we are considering that here the heat will be positive. Okay, enthalpy of formation or the heat of formation will be positive at that time. Okay, now the next one, standard enthalpy of formation. This is very important topic. Okay, what is the meaning of standard enthalpy of formation? Now when we are going to calculate the enthalpy of formation, always we have to understand that there is some standard condition at which, because we know that the different reactions are take place at different pressure and temperature. Okay, so for all the elements we have make one reference point through which we are going to measure the simple heat of formation. Similarly, as earlier we have discussed in chapter number 1, that always we take atmospheric pressure as a 1 bar, that is our reference line, and always above the atmospheric pressure we are considering the gauge pressure. So all the device which is behave or which is working above the atmospheric pressure, we are calling it as a gauge pressure. So the atmospheric pressure is the reference line. Similarly, here for the heat of formation we are doing same kind of reference, one reference point from which we are going to measure the enthalpy of formation. So that is known as the standard enthalpy of formation. So I have described all the things here, that the magnitude of delta H for the reaction is depends on the physical states. Okay, so always you know that when there is a gas, there is a pressure or temperature will be vary according to the component by component. So always we are going to fix one standard point through which we will measure the enthalpy of formation. And at that time, at that standard condition, the enthalpy of formation, that standard condition is the 1 atmospheric pressure and the temperature equals to 25 degrees Celsius for the 1 mole. Okay, this is the standard condition. Okay, and at this condition we will measure the enthalpy of formation. Okay, so this is the standard condition, that pressure equals to 1 atmosphere and temperature equals to 25 degrees Celsius. Okay, so this is our standard condition. And always at the standard condition, the substances we are occur naturally, or in the substance we are in the free state. At that standard condition, their enthalpy of formation will be 0. As for example, the oxygen will be at 1 atmospheric pressure and at 25 degrees Celsius, the oxygen will be in its natural state. If the oxygen is in natural state, then the enthalpy of formation for the standard condition, it will be 0. So if we write the standard enthalpy of formation for the oxygen, we will consider it as a 0. Similarly, for the carbon dioxide, we can write it is a 0. Similarly, for the carbon freely available in the standard condition in the form of graphite. So always we take the carbon in the form of graphite, the standard enthalpy of formation for the graphite equals to 0. Okay, so we can write for the standard condition, that is the pressure equals to 1 atmosphere and temperature equals to 25 degrees Celsius, we can write for the oxygen, for the carbon dioxide, for the hydrogen, for the N2, for the graphite, all will have the delta HF value equals to 0. Okay, but it is for the standard condition. If you change the condition, then obviously the enthalpy of formation will be changed. But for the standard condition, that is the pressure equals to 1 atmosphere and the temperature equals to 25 degrees Celsius, it will have 0 value. Okay. So I have also mentioned here the standard enthalpy of formation for any element in a standard state, it is 0. By definition, that means for all the substance at temperature here 25 degrees Celsius, that is a 25 degrees Celsius, and pressure equals to 1 atmosphere, for 1 mole at freely naturally occurring state, the standard enthalpy will be 0. So as earlier I have discussed that all this substance will be naturally occurs or will be freely available at this condition. Okay, right? Now next is the heat of reaction. What is the meaning of heat of reaction? Here you can see the standard enthalpy of the reaction is the enthalpy change that occurs when the reaction is carried out with all the reactants and the products. Okay, so we can write simple, if there is a two substance, one is the A and second is the B. Okay, and there is a small a. Here you can see this equation that ABCD, capital A, capital B, capital C and capital D, these are all the chemical substance, and here small a, small b, small c and small d are the number of isometric coefficients. Okay, so we can write the A into A, finally A and B, this A and B are the reactants, and finally from this A and B we are going to make one product, that is the C and D. Okay, so from the mixture of A and B finally we will get the product, that is the C and D. So at that time how much amount of the heat is required? That heat is known as the heat of reaction. Okay, so if there are number of substance, then we can write the heat of reaction like this. Okay, so here you can see these are, finally we can write the magnitude of the delta H is the sum of the standard enthalpies of the heat of formation of the product, each multiplied by its appropriate coefficient that we have already discussed, minus the sum of the standard enthalpy of formation of the reactants. Simple. As earlier we have discussed that A and B were the reactants and C and D were the products. So when you minus the reactant from the product, finally you will get the delta H for the reaction. Here you can see simple that here you can see these are the reactants. So the enthalpy of formation for the reactants, you have to do the sum of this, and finally the enthalpy of reaction for the product, C and D are the products. So what you have to do, you have to add the products, enthalpy of formation for the product. So product minus reactants will be give you the final enthalpy of reaction. Okay, so in the mathematical terms we can write here as a sigma of enthalpy of formation for the product minus sigma of enthalpy of formation for the reactants. Okay, so this is simple known as the enthalpy of reaction. Okay, now our last topic of the chapter is the hash law. What is the hash law? Simple, we know when we mix one carbon and two oxygen, finally it will become the CO2. Okay, so this is the one line process. Okay, so what does the hash law say? Hash law says that if you are doing the equation in one step, or if you do the same reaction in number of steps, then finally the change of enthalpy for both the condition. If you do the reaction in one step or if you do the reaction in multiple steps, the change of enthalpy will be same for both the condition. Okay, so this is the simple statement of the hash law. So sometimes this hash law is also known as the hash law for the constant heat summation, or hash law of the hash law of the heat summation. Okay, this hash law was given by the Henry Hash in 1840. Okay, it says that the heat is absorbed or evolved in the chemical reaction is a fixed quantity, and it is independent of the path of the reaction or the number of steps which is taken to obtain this reaction. As earlier I have discussed that if you make C plus O2 is equals to CO2, this process occurs in one step only. But if you do this process in number of steps, okay, first if you take one carbon and one oxygen, and then it will make one carbon monoxide. After that, if you add one oxygen in carbon monoxide, then it will become the carbon dioxide. So here you can see this process is occurring in two steps. But if you make it in one step, that carbon plus 2 moles of plus O2, then it will automatically become CO2. This process is finalized in one step. Okay, so this both the process will the enthalpy change for both the process will be same. That is the basic meaning of the hash law. Okay, so let us take the same example. Here you can understand the basic idea of the hash law. Here you can see there is a one carbon and two oxygen. Finally it will mix the CO2. Okay, here it will mix the CO2. So the delta H for this condition is minus 94. Okay, simple. So here the process is occurring only one step, that is the carbon plus oxygen will make the carbon dioxide. Okay. Now we can also do the same process in number of steps. Like here you can see, when one carbon is mixed with the one oxygen, it will become the CO, that is the carbon monoxide. Now this and the delta change for this carbon monoxide is minus 26. Okay. Now next one is the carbon monoxide will again react with one oxygen and it will become the carbon dioxide. So ultimately what we are doing, from this carbon carbon and oxygen we are making the carbon dioxide, but in this condition it will takes place in only one step, and here you can see there are two steps, but ultimately what we are doing, we are making the carbon dioxide. Okay, so for this enthalpy change is minus 67. So here you can see the enthalpy change is here 94. Okay, so if you do the sum of this delta H, this first one delta H and this second one delta H, then you will get the same answer, that is the minus 94. So here you can see this is the benefit of Hess law. What does the Hess law say? That if you do the reaction in one step, or if you do the reaction in number of steps, the final enthalpy change will be same for both the condition. Okay, so finally we can conclude that if we do the summation of that, we will get minus 94. Okay, so this is the final answer. So this is the basic meaning of the Hess law. So hope you get clear idea about the Hess law. Okay, so we will meet soon in our next lecture. Thank you for today.